Hey everyone, this is Peter Haumer from IBM. I'm greeting you from the sunny but perhaps a bit windy and cold California Bay Area. And I want to talk to you about modern enterprise application development for the mainframe in the cloud. So in contrast to perhaps some of the other presentations, I'm not representing one specific project in the Eclipse Cloud Tools community, but we went through the journey of utilizing many of these tools and built a commercial offering on top of them, right? So we want to tell you our story of why and how IBM systems moved from the green screen development to the hybrid cloud. There was, of course, many stages in between as well that I won't talk about today, but the idea really is to show how open source, particularly the Eclipse cloud development tools, paved the way for us and helped us really to achieve our goals much, much faster. And also like how we are contributing back and how things that vendors do might also be really good for the open source community. So that's a win-win for everyone, right? So we'll provide, again, this vendor perspective that participates in open source, but also then really wants to sell tools on top of that. So as you will see, we have free components as well as commercial components layered on top of each other. As not perhaps everyone is familiar with mainframe, I know from experience there's always someone asking, mainframe, is that still a thing? And it's most certainly is, particularly if you talk to IBMers, right? So mainframes are a key part of our portfolio. So, and you might not even realize how pervasive mainframe is in your daily life. You might be able not to even get through your daily routines without interacting indirectly with the mainframe, right? So you use your credit card or your Apple Pay at Starbucks or a shop, right? That transaction will be in the end processed by a mainframe. Any flight you book, any hotel you book, most likely going through a mainframe, right? So you can see billions of transactions every day, and massive amounts of business data is stored on mainframes, and we'll go through those. And it's a big market. Perhaps if you're a tool vendor or somebody selling tools as well, to sell development tools too. Right, so here's some more examples. So retailers, worldwide banks, airlines, insurance, right? So all of these utilize mainframes as they provide some unique properties that you won't get in the distributed space, right? So we just announced the latest increment. Every 2 years, there's a new release of the latest hardware. So Z16 was just announced, and it has some new breakthrough technology in it as well. This new Teleron processor, for example, has AI on the chip, can run billions of AI operations on your transactions, finding fraud in real time, end-to-end encryption and quantum secure encryption on all areas of the architecture and so on. So the list goes on and on. And as you can see here in these diagrams, right, so you can still combine this with horizontal scaling, putting web layers on top of this, but in the end, there might be a mainframe that will perform a massive amounts of transactions processing and managing the data securely and doing many things that the normal user is not aware of. So the demand for IBM Z systems and skills is very high, right? So that's why I'm telling you all of this. So this is still a platform of growth. The largest shops out there, they're utilizing them. And so dev tools and DevOps is a key topic there. Right? Surely there's a lot of legacy involved with these systems. Some applications are maintained for many years, sometimes even decades. And they still have to run, they still have to be maintained. And often people cannot just quickly go and migrate them off a mainframe and perhaps don't even want to. Right? So the idea is really that you can have, as if you're perhaps a student, have really great career in the Z-System space because these are highly sought after skills. And the thing that we're interested in now in my team, the IBM WASI project, is to really provide a development platform that can integrate with all the other development platform that an organization runs in parallel. So distributed development in particularly, and modern tools and development frameworks and principles are key, right? So when you hear the keyword enterprise modernization, people not talk about replacing or rewriting the apps these days. They really talk about modernizing the way they develop software. So providing the same principles of agile development and this cultural change also to the mainframe application development world, and be able to be integrate with other efforts, like you saw in my architecture picture, those layers of middle tier and web tiers that people put in front of that, so that all that development is part of the same development lifecycle, that you same have the quality of delivering faster on the mainframe side as well as the distributed side. And so choosing the right technology is important for that, right? So which leads back to the Eclipse Cloud tool project. So open source is on the radar of almost all of these organizations that utilize mainframe, and being able to deal with the skills gap. So being able to hire a new developer out of university, out of another company that has the skills required to do the work, and to bridge that gap utilizing the same tools and processes, of course, the first step. So we want to achieve that basically if you're familiar in writing Java code using VS Code, that you can very quickly do the same thing with a ZOS application that might be written in COBOL or PL1, but can utilize the same tools and the same ways of working as you're familiar with all these other technologies. So our vision is that for ZOS to be widely available and a vibrant choice as a platform for hybrid cloud development, right? So in addition to utilizing all these new tools, we want to be able to even bring the entire development stack into the cloud. So talking cloud native developing for ZOS in the cloud, as well as you would see, running ZOS in the cloud, not for production, right? Nothing beats real hardware, but for development, and to give developers more flexibility in terms of giving them a development infrastructure and the tools that they need to do their job. So this is a slide that we show to our mainframe customers, right? So they're used to this technology stack. You can see here at the top, there's some very proprietary tools out there. ISPF is that green screen editor that I can also show you in a moment, of how many people used to work on mainframe applications. And then there are vendors who produce as I said, proprietary solutions that run on the mainframe themselves, that are very specific to how you build and deploy applications in the mainframe, that have a very steep learning curve that requires developers to know all about that. All right, so the distributed space, you can see here, perhaps this is not a totally up-to-date slide, but some examples of the tools and technologies people are using. So our vision is to have this hybrid approach, bring the best of both worlds, focus on the modern tools, make all the modern tools work on or with the mainframe, and integrate them with each other so that they can seamlessly go from one to the other. So here's another example of technology choices that you can pick from if you're in that space for the different stages of the life cycle. And many of these icons and products you're probably very familiar with. And then there are trickled in here some very specific mainframe ones. And then at the top left side, the coding piece, that's what I'm going to focus on today. Utilizing our editors like Thea and SHEA. That's most interesting to you here, this audience, but we could talk about any of these areas in detail as well. But today we'll focus on the developer. In particular, two types of personas that we're interested in. So I mentioned that the young developer coming out of the distributed space or fresh out of university, right? Kids these days, my friend has high school kids, they already learn Git to share homework and collaborate in the high school age already, right? So that's technology that's totally pervasive that everybody's using. And so Deb is perhaps a developer who started early with technology. She knows what editors she likes. She might be a VS Code fan and uses Git for all kinds of work and non-work related activities, and that's a key audience. Let's bring in Deb on board to this world of mainframe development. And versus Kathleen, who might be an experienced developer who worked on the green screen before. So we don't want to alienate her either, that we throw all these tools at her that she needs to learn, right? So we'll find the right way to onboard her as well, and work with Deb to agree on the right tool stack that they're interested in. On the left-hand side, you see also other roles that play a key role, like Todd, the cloud operations admin that will deploy environments such as Eclipse SHEA into the cloud and integrate this with other technologies like a build pipeline or our Z virtual servers that we're deploying into the cloud, which is then prepared by Zach, the ZOS system programmer. So those are the people who maintain the operation system that runs on these mainframes, right? So perhaps I should have mentioned that, right? So our target audience is also not only using this different processor architecture, right? It's not x86, it's S390X, which is this modern processor that I mentioned, right? The Talon processor that performs like these artificial intelligence operations. So the instruction set is completely different. The compilers are different, and all the technologies that you run on there need to be working on those. But Linux on Z is a thing that you can run in these mainframes. You can run thousands of virtual machines on one mainframe that are all their own individual Linux box, and IBM is providing all software really that is necessary for these environments. But for ZOS, which is a completely different operation system, we need Zach to prepare the environment and help out with that. So here's a run through our journey on the principles of the architecture that we applied. So we'll show you an architecture picture in a second and demo many of these things. But the idea is really to build up these layers of either things that are built on top of each other or are individually replaceable to come up with this portfolio of tools that we can run in the cloud as well as on developer laptops and so on. Right? So started out with working on the US side, providing REST APIs for interactivity, because when you develop an application for the mainframe, you don't run anything local. Like you have the source code in your editor on your laptop, but you have to compile it on the ZOS system. Like those COBOL compilers and so on, they are only available for the ZOS operation system. Same thing if you want to run a debug session. You would start a session first on the ZOS host, and then you need to use a client like VS Code locally or an editor in the cloud like Eclipse SHEA to connect to it. So you need all these protocols in place so that they can talk with each other. The next thing we did is put client SDKs together in languages like TypeScript and Java, as well as command line interfaces that can execute operations remotely from my development environment to these systems. So here we participate in another open source project called Zoe, which is run by the Open Mainframe project, where we're participating on the Zoe CLI, the command interface, as well as Zoe Explorer, which is then the graphical UI that utilizes the same SDK to now, instead of executing command and operations, giving us tree browsers to look at file systems, right-click operations, and menus to do these things graphically in a VS Code extension. And then we created a language server. So everything you heard from Stefan earlier about C++ and the challenges to build these languages server and integrate them and select the right ones, we went through as well, with the additional challenge that then you like pass these things locally, but then you would execute things remotely. So the actual compilation debugging, as I mentioned, will be in the remote system. And we utilized our legacy system. So we had a Eclipse Java SDK implementation for many years out in the market, right? So the classic Eclipse plugins where we had our parsers implemented for these different languages, and we were using them. So our language servers have been written in Java and are available in these modern editors now as well by sharing this code base. So when we support a new version, like those languages are still alive, right? There's a new version of COBOL coming out in 1 month that's already been announced, COBOL 6.4. So updating the parsers for these language enhancements, we do only once, and then all our editors will be able to utilize that. And that's really thanks to this great language server innovation that we're utilizing as well. And then we create specialized extensions as well. So we have a free editor out there. This is the open editor for language editing, but then debug clients or specialized things like DB2 database tooling, they require also commercial components in there. And so some of these free, some of are commercially available as well. And then we implemented Eclipse SHEA plugins on top of that. So that's a nice thing that SHEA can run VS Code extensions. But of course, you have to I will show you some of the lessons learned we had about that. And then the commercialization of Eclipse SHEA, we utilized from Red Hat, the code-ready workspaces. That gives us a lot of additional features and like all Red Hat certified images that are all based on UBI and have been scanned by Red Hat that we can then use for commercialization. And it runs in OpenShift, which is our Kubernetes of choice in which that we want to support. And then gives us things like air gap support, image pullers, and so on. That work really well in this way. But the OpenShift, the Red Hat code-ready workspace itself is an Eclipse licensed portfolio of repositories. And so the changes that we apply to this, we donate back, or we also publish our source code on how we modified that. So that's bullet point 9 here, fork this code-ready operator, which we have done, and to address some IBM requirements. And some of these we're going to donate back, like the license accept button that we just added, or our Prometheus integration, which is probably more specific to what IBM needs to do. But then through the IBM Cloud certification, we're finding security problems and improvements that can have to be applied, and we are donating those back to the Eclipse SHEA project as well, right? And then the last thing we do is we certify this. So everything we do is Red Hat certified, but as I will show you, IBM certification adds many, many more checks on top of that to really harden things for security and scalability and so on. All right, so I won't be able to go through all of these. For many of these bullet points, I have perhaps even an anecdote to tell, but here are some of the key lessons they learned when we utilize projects like Thea and SHEA with these platforms in mind, right? So the key thing is that when you write a VS Code extension, you need to immediately continuously test this with Thea and SHEA, right? So Thea has re-implemented the VS Code APIs, but it's not 100% perfect there. The API is missing. There are bugs often that appear. Many regressions happened in the past, right? So it's an incremental process of dealing with these types of things to ensure the compatibility on all these platforms. So you need to test with SHEA, as well as you need to continuously test with SHEA, because SHEA adds another level of complexity to this, as it distributes things into multiple containers that run in pods that can't immediately always access each other. And so we run off many increments of learning there as well, right? So also, other VS Code extensions might not run in there. So we have a YAML specification for one of our metadata files, and we utilize the Red Hat YAML VS Code extensions for that, but that not always runs in the latest version of Thea or SHEA. So you need to go back a couple of versions to a version that actually works, right? The latest version of Red Hat uses a newer VS Code API that Thea has not implemented yet. So you need to be, again, continuously testing and evaluating the right combination of technologies that you're combining with each other. Or you have to start doing your own things, like when Thea stopped publishing their Docker images that we required for our test automation, we then basically picked that up ourselves in the Zoe Explorer project context, and we're publishing them now to Quay. They're publicly available there, so if anyone else looks for Docker images that they want to use for test automation of the Thea releases, you're happy to use them, and they're there for you. When you design your VS Code extension, right, you need to be careful on utilizing technology that actually works well. Like we are really skeptical of web views, right? We found a lot of problems with those as a run on SHEA in different containers, and loading resources from the disk. It could be a problem, as the resources might be in a different container. So you have to design all these things with SHEA in mind. Or APIs that are not implemented yet, like the VS Code secrets were not implemented for a long time. Now they're available, and they get mapped to Kubernetes secrets, but a long time you couldn't use any of those extensions or APIs that utilize Keytar. Right, so or there's no code snippets gallery in Thea, so you have to find other ways, like with control space, to provide your code snippets. In our case, we're shipping more than 200 code snippets with our extension. So that was something we just had to work around with. So you can see this is a pattern of testing, evaluating, combining different things, and making sure it runs on all of these platforms if you want to support them all. So one thing that we also tell people to bring Kathleen on board, right? So the person who might not have the skills yet is really look at the advantages that you get with Eclipse SHEA, right? Surely there's a higher cost of entry to utilize that. Here's, for example, a list of all the things Deb would have to install to run VS Code with all these tools on her laptop, right? So, and imagine development organization with 200 developers or something like that. They all need to have all the same versions and configure all of these things together, right? Install of them, or often development organizations require that these tools get centrally installed through automation to somebody's laptop, and the developer themselves don't even have the permission to install stuff. So that's where really SHEA would come in, right? So you define your technology stack, you create an image with all your prerequisites, you create a plugin in which you combine the right versions of your VS Code extensions. You might even mirror these VS Code extension in your plugin registry and publish all these things out, right? SHEA is entirely customizable. So here you see our dashboard where we should only show you only the technology stacks that our customers are interested in. So they don't want to see like PHP development or .NET that you get with a regular SHEA. So we eliminated all of those, picked only the languages that work on ZOS, and then added our own. So you can see our tiles here, adding a complete stack of tools for PL1 and COBOL and Rex, as well as a Zoe, C command line APIs, as well as the debugger and so on. In our latest release, we even now added Ansible, because that's a popular automation framework that we also support through many of these scenarios that we're doing. And then again, I mentioned the customization, right? So this is very important to deploy the Eclipse SHEA organization, that you customize this for the experience that you need. Particularly also, we tell this to our customers. So we give you a good starting point. Now you want to go in though and examine what technology stacks the organization actually is using. Perhaps for different projects, you need different combination of things. You need to bring in third-party stuff. And that's what you do, right? So you create your own plugin registry, your DEFA registry, you publish them. So this is well documented in our online documentation, as well as the Eclipse SHEA and code-ready docs give you good examples on how to do that. And then really all Kathleen has to do, she comes in, I'm in a particular project, I have a tile in here, I specify at the top of my Git repo, I click on the tile, and she's up and running. All right, so here's a combination of those different things that I mentioned, right? So one of the technology stacks that we're providing. So this is for the on-prem deployment. So assuming a customer has OpenShift running in their organization, and it can be on x86 or on mainframe. You can also run OpenShift on mainframe itself. Inside Linux on Z, and then deploy these technologies in there. And so you see code-ready workspace in here with some of those components that we're plugging in, and the sandbox, which is an emulated environment that runs in OpenShift. So this one actually emulates the OS and the processor and operations entirely in software running on x86, giving developers their so-called sandbox that they can use for development and playing. As well as we're integrating then with these rich clients. So our VS Code extension can access this, our Eclipse extension that we have as well. You can access it with your green screen if you want, as well as then integrate it with things like pipelines, so Jenkins, GitLab, Tekton. So we're providing examples how to do this and set this up. Here's our in the cloud IBM cloud deployment. So that's what I want to demo now, that you can entirely just go in and do everything in the cloud without having any hardware yourself. You just need a laptop in a browser. So you get your ZOS system in the cloud. It's called Vault as a service. And then you deploy code ready on OpenShift there as well, and utilize this entire environment. So here's the cloud deployment model that I'm going to show you now. So I'm going to into the IBM cloud and create a so-called virtual private cloud, and then deploy various things in there and give access to these things. So let's have a look at that. here in the demo. So I'm coming in here just into IBM Cloud. That's the main entry page, the main dashboard. You can see a summary of all your resources that you have in here. And then you have a catalog that you can deploy various things at a service. So what we're interested in is building up really infrastructure as code, right? So it's called virtual private cloud. So you basically specify the network that you want to set up, and how you want to protect it, how you want to access it with VPNs and so on. And then the things you want to deploy in there. So you can deploy clusters in there, you can deploy server instances in there, and configure this entirely through automation, right? So everything has a UI in here. So here are my virtual server instances that I'm using. I can do this all through graphical UIs and create buttons, but I can also do this through Terraform and Ansible and entirely automatically create a virtual private cloud, secure it, give people access, deploy infrastructure in here, and so on. And so here I'm running now ZOS systems. So that's something that we have announced. It's not available to the public yet, but very soon, where you can now, instead of an Intel system, you can actually get your real hardware Z system in the cloud for development, and then there are various regions where this will become available, and then run ZOS as the operation system on here, right? So you can run other Linux distributions, but you can also run ZOS with a dev and test environment that then has a lot of our components in here for the clouds, for the development pipelines and tool chains that I was outlining for the stack that you can use. And then just create this and deploy this into your environment. And in addition to that, you can deploy other things. So let's go back to my infrastructure here. I've also deployed things like GitHub in here, right? So if you perhaps don't have your own GitHub enterprise server, you can deploy a GitLab server here into your VPC, which I'm using here for source control and so on, right? So the catalog gives you a lot of different choices. So GitLab in here, but also you can deploy OpenShift into this one. And that's what I'm doing here as next, right? So I'm creating an OpenShift cluster. I wouldn't walk you through this. I don't have a lot of time left, in which I then deploy things. So here's my OpenShift cluster that I have created that runs in the same network, that's protected through VPNs as well, and has access now to my virtual server instances. And now I can deploy code-ready workspace here. So as I mentioned, we have a customized version called Warza Developer for Workspaces that allows me now as an operator to be installed in here, which I've already prepared. So I have the operator running in here, and now I can create instances through this. And so you can see that we're modified some of these things in World. So we have a license accept in here. So we require users first to review our license agreement and then accept that license agreement. So these are changes that we did to the Eclipse SHEA operator that we're intending to donate back to the project if there's an interest for these types of functions, and then deploy code ready into this cluster and have access to it, right? So then the end result will be instances in here. I've got one running already. And then this is the URL that you would provide to your developers. You manage their accounts, and that will be the dashboard that they can log on to that you saw my slide earlier, where you can now select the tile and start the workspace. So I've got this already running in here. So here's a workspace that I've created, and now you can see full language support for these languages. So COBOL, PL1, and so on. And it's something like that Deb is entirely familiar with. So you have operations such as peek or references, which is something that traditional mainstream developers, of course, do not have, right? So the power of language servers and the ability to utilize these technologies is key here. And now this is integrated with other things like a GitLab pipeline. So if I would make some changes, I can push these changes through the Git perspective, and then it would run a pipeline built in here. So everything running entirely in the cloud in this virtual private environment that I showed you that I've created here. All right, I see I'm out of time. So Perhaps the resources might be interesting. I will provide those slides as well. There's another section on certification that I didn't get to, but there are more in-depth videos available as well, and more information if you're interested in trying these things out, getting hands to it, or just seeing demos that go into more details than I was able to show you. Okay, let's have a look at the question. So question number one, how can this information make it into the education system? I really feel this is a gap at most school programs and some knowledge or every developer should know when they graduate. So yeah, we do work with a lot of universities. There's an IBM-driven training program as well called Master the Mainframe. Or it has actually been renamed now to IBM Z-Explore. That's been utilized, and that's what many universities use. So there are like yearly almost 20,000 students worldwide participating in this Master the Mainframe program. It's like a learning program as well as a competition where you can win prizes, and many universities plug into that and utilize that for their training classes as well. Question number two is the support for other languages. Yes, so I was showing you COBOL, but this is Eclipse SHEA. So you can nicely integrate this, and that's where the customization comes in. If you want to use Python or Java in the same project, and there are a lot of projects out there that use COBOL as well as Java and combine these, so you would just create a plugin or combine different plugins in a dev file in Eclipse SHEA to combine them and have all the languages available to you in there right away. Are there any things, plans to contribute things like better snippet support? So definitely we always would be interested in supporting these types of things, but we also have to find the right priorities. So our resources are also limited, believe it or not. So at the moment, the highest priority for us were always our security related. So if you look at the slides that I had about certification process and so on that we need to go through, in addition to Red Hat, we basically spend most of our time fixing security problems in like reference images that come from other vendors, as well as those dependencies that projects like Thayer and so on depend on. And so those are the first commits that we're donated back to Eclipse SHEA, adding specific features to Thayer. We would love doing that, but it's always a resource question. Please feel to contact me. You can see my LinkedIn address if you want to discuss any more of these things further and have other questions. Thank you.